Hello friends, years ago I made a few clock videos on this channel. I created clocks by casting epoxy onto 3D printer prints. Years later, I returned to a similar concept. Let's make a few more clocks. Friends, recently my wife and I started working with epoxy in our spare time. It's a very enjoyable and aesthetically pleasing field. But we also like to add a little 3D printing to it. We've been doing it for years. The last time I made 2 clocks was 4 years ago, by casting epoxy onto 3D printer prints. Since I'm making so many things out of epoxy these days, I decided to go back to those days. Let's make a special epoxy clock together for New Year's. First, let's start by making a case to hold the clock mechanism. Let's put these pre-made clock mechanisms inside. Let's create a circle around it. This will be the center of our clock. I drew a case in SketchUp according to the movement's dimensions. I also put a circle around it, making the clock's center round. This will be the exact center of the clock. But let's not leave it empty. Let's embellish it a bit. I recently held a sign reading Merry Christmas in the hands of a Santa Claus figure to make epoxy coasters. I could use that Santa in the center of this clock too. But I need to drill a hole in the center for the clock mechanism shaft. SketchUp isn't very good at modifying STL files designed elsewhere, so I'm doing the center drilling in TinkerCad. I drilled an 8mm hole in the center of the Santa figure. Now I'm going to my 3D printer's slicer program and assembling the round case I made with the Santa Claus figure. First, I align the holes in the middle perfectly so I don't have any problems inserting the clock mechanism. I assemble and check the figure. Well, it seems a little too plain. I need something new. I decide to divide the clock into 4 parts. I decided to draw lines for 3, 6, 9 and 12 and add their numbers. Of course, this requires some work. I draw the lines in SketchUp. However, I prefer Anycubic's Slicer Next program for text and lettering. After importing the STL files I created from SketchUp, I add the numbers. I decide on the fonts and their placement. Make sure all the pieces touch the main body. It's generally useful to use stencil fonts for this method. In such fonts, for example, the space inside the letter O connects to the outside. Using these fonts on a 3D printer will also be beneficial for your text's connection to the main body. It still seems like it needs a little more movement. For each hour, I'd better make a protrusion on the circle. I measure the angles, mark my circle at 30-degree angles and divide it into 12 equal parts. I make a notch at the section corresponding to each hour with a small triangle. This seems better. Now, let's take advantage of our 3D printer's color capabilities. Let's paint our figure. However, printing in color with these types of single-head printers can often lead to waste. So, if your printer doesn't have a separate print head for each color change creates a lot of waste, slowing down the printing process. Therefore, it's best to keep color changes to a minimum. The best way to achieve this is by layering. Keep in mind that with 3D printer brands like Bamboo, Anycubic and Creality, when printing in multicolor, make sure each layer is a single color. This way, as the layering continues, frequent filament changes are avoided. As of November 2025, when I was filming the video, no manufacturer has solved this problem, except for brands like Prusa and Snapmaker. However, the Prusa and Snapmaker have multi-head printers. Anyway, that's the subject of another video. In short, I'm painting my model layer by layer. By the way, to make printing easier and reduce the amount of support, I also separated the round center core containing the Santa Claus figure from the case where the clock mechanism will fit. I'll be printing these separately. I want to use as little support as possible and conserve filament. Similarly, after completing my work, I slice the pieces in Slicer. I monitor the printing process. I especially check the filament change times value to avoid excessive filament changes due to my painting. Each filament change wastes 1 to 2 grams of filament. I try to eliminate unnecessary filament changes by adjusting my painting methods. I don't make any special changes to my print settings. I prepare the model for printing with a 0.2mm layer height. After making final checks, I send it to the printer. The printing time is approximately 1.5 hours. Let's see. Let's print our Santa. Yes, in about 1.5 hours we have our Santa Claus. Of course, it took 1.5 hours to print, but the design steps I've described so far took much longer. We went through it all in just a few minutes. However, the cycle of thinking and designing again, along with the millimeter calculations, is a much longer process. Anyway, Our print is beautiful. I also attached it to the black movement case I printed. I'm testing it to see if it fits inside the movement. It's great. The calculations seem to have worked. Let's attach the hands to the watch and see how it looks. That's cute. Let's also put in a battery and test it. Is there any friction or snagging? It works perfectly. No problems. It doesn't look bad at all. I think it's quite good. Now, we've finished our work on the 3D printer. We've moved on to another stage, the epoxy resin stage. For this, I'll use a different method than I did years ago. Years ago, when I poured epoxy, I didn't use a mold. This time, I'll use a watch mold I bought from China. I'll be pouring the epoxy in a silicone mold. Actually, I don't have much space for this. My camera setup is on my small desk where I do electronics and soldering. This isn't exactly suitable for pouring such a large mold, but I'll try to make the pour here so you can see it. I'll clean it up a bit with alcohol. Of course, a little alcohol can't remove the marks of the years. Epoxy is harmless when it dries, but the fumes it releases during the pouring and drying are quite harmful. So be sure to wear a mask. I wore my mask. I felt like an artist. Also, epoxy is quite messy. It's very difficult to clean up if you get it on something. So be sure to wear gloves. I have a 1:2 ratio of Dipon epoxy, a German product. Canister A contains epoxy and canister B contains hardener. A 1/2 ratio means that if I'm pouring 2 parts of A, I should pour 1 part of B. I grab my scale and prepare a mixture. I've transferred the contents of these canisters into smaller bottles. I pour 80 grams of A, then I add 40 grams of B, making a total of 120 grams. Then I start mixing. Mix for at least 2 minutes. The mixture should become clear. It's important to pour these slowly and mix gently, but my working space is quite limited right now, so we'll have to wait a few bubbles. Then I take some alcohol and thoroughly clean my silicone mold. I also run a little water mixed with hand soap over the mold to prevent sticking. Now let's try our Santa Claus in a silicone mold. Will the hole in the center fit? The theoretical calculations didn't disappoint in practice. Everything seems complete. So let's start slowly pouring the epoxy into the mold. I pour the clear epoxy mixture I've prepared into the center. Then I mix up some more epoxy. I add a little red paint to it. The edges should also be a slightly lighter red color. It's perfect for Santa Claus. But this is where you really understand the importance of the workspace. The light and the floor aren't ideal for pouring epoxy. I can't mix it very well. There are areas where the paint clumps together. But let's continue. We've made a lot of progress. After the pour is complete, I use a lighter to remove any bubbles that have formed on the surface. Finally, I cover the casting with a plastic bag to prevent dirt and dust from falling onto it. After a few hours of waiting, I pour a few more layers of epoxy until it reaches the height of the silicone mold. This way, we'll both encase our 3D model in the epoxy and add volume to our clock. It won't warp or bend. The weather is cold. That's why I prefer to wait 2 days after the last pour. It cures quickly in the summer, but in the winter, the epoxy cures quite slowly. So, after 2 days, I check the epoxy and start removing it from the mold. But what a pain! I've used epoxy molds before. I've cast small pieces like chess pieces and large pieces like chessboards, but I've never seen a product so difficult to remove from a silicone mold. The cold weather probably plays a role, but the silicone mold definitely doesn't seem to be very high quality. It's completely ripped and punctured in one area. We'll repair it. I'll show you how. Anyway, I inspect the resulting product, but I'm not happy with it. It doesn't have the clear look I'm looking for. Also, the amount of bubbles in the core is quite high. There are some unsightly casting marks in various places. I wouldn't want something with a Christmas theme to look so hazy. It's hard to say, but after days of work, the resulting product is garbage. But it's not entirely a waste of work. Experience is experience. In the meantime, let me show you how I repair silicone molds. I've tried this method before. It works. If your mold has small holes, you can fill them with a quality aquarium silicone. Then wait at least a day. Once it's dry, you'll see that it's better than before. It also doesn't stick to epoxy at all. So, should I end this video like this? It wasn't bad actually. It explained the process. However, I didn't feel comfortable posting something I was going to throw away as a video. Let's make a new Merry Christmas clock. Let's design a center hub and print it on a 3D printer. And a Santa Claus figure in the center holding a Merry Christmas sign. And a case cover and hanger on the back. Our model is complete. Now let's start pouring a lot of epoxy. Let's prepare a 150-gram batch and pour 1 layer of clear epoxy first. But do it in a comfortable place. Then let's get to the fine work. Spread the epoxy thoroughly with a silicone brush. Remove any bubbles with a lighter. After 3 to 4 hours, let's move to our new table where we set up our video setup. The first step in the epoxy process is cleaning, of course. Let's place the models we've taken from the printer on top of the first layer. This time, let's reverse the clockwise direction so the top is facing the front. Let's see what's happening from above. The outer layers should be transparent. So let's pour the clear epoxy onto the outer layers. Let's wait a while for the epoxy to gain a light consistency. The inner layers are red. Let's start pouring the red epoxy. It's okay, it'll make the transition smoother. However, we don't want it to mix completely and become cloudy. That's why we waited a few hours after the first pour. Let's continue pouring additional layers of epoxy every 3 to 4 hours until our clock reaches the desired thickness. Meanwhile, I printed 12 pieces for the hour markings using a 3D printer. I'll glue them to the clock. But first, we need to remove the clock from the silicone mold. Our Chinese-made clock mold failed us again. It stuck everywhere. The result is a few cuts and a hole. Let's attach the lines to the clock with epoxy glue. I use an adhesive called UHUENDFEST 300. It dries a little slowly, but it's very durable. The lines dry after about 2 hours. In the meantime, let's try the clock. Are the dimensions correct? Are there any snags? It looks like we have a stylish clock that works beautifully. I attached the clock mechanism to the case with instant adhesive. I'll be protecting it with a cover anyway, so there's no need for epoxy glue. I built and attached this case too, but I never took a video of it. It protects the clock mechanism and has a wall hanging hole. Yes, days of work. Hours spent in front of the computer. After 200 grams of filament, nearly half a kilo of epoxy, and several unsuccessful attempts, we hang our clock in our room. It wins a competition with the nail on its side and is crowned the room's beauty queen. I hope this was a helpful video for you. See you in the next video.